Whenever the wave transfers, what does it mean? Only energy is transferring, not matter or not particles of matter. So particles of matter will never transfer. Only what will transfer? Only energy. So for example, sir, I want to check it, only energy is transferring, not matter. So you can take one bucket of water, and if you're having it, and put some rubber cork in the water. A rubber cork, you can see the rubber cork, if you drop it, so that the waves will start moving from that point, it will start moving backward, outwards. They will start moving outwards to the end of the bucket. So they will reach us to the end of the bucket. But the cork will be keep on bouncing up and down in the same position. Same mean position, it will be keep on coming up and going down, coming up and going down. So what does it mean indicating that? Particles are not moving. What actually moving here? Everybody, only what is transferring, guys? Only energy will
Energy.
get transferred and not the matter. And not the matter. That is what you have to remember. Understand, Kavya, Alfin, Rasani? Any doubt, please let
Yes,
me.
sir.
So this is what is basically happens. Now, if you understand this concept, now we are going to discuss propagation of wave. So what do you mean by waves? So now you all clear, I think. Now we are going to study propagation of wave. Please make it heading and do it. Just a minute. Yaar option, Agalya option do it. 8, 9, 10, 11. Mr. Mukesh, understand?
Yes, sir.
Okay. So we'll proceed now. Everybody? Yes, propagation of wave. Right. Propagation of wave means the motion of a wave. The motion of a wave from one point to another. One point to another. That is only called it as propagation of wave. Next, medium. These are the terms which is required to study the sound chapter. Medium. So you all studied 8th class. If you want to propagate the sound, definitely we need a medium or not. Everybody? Yes or no?
Yes, sir.
Yes. So with medium, the sound cannot be transferred. With medium, sound cannot be without medium, sound cannot be transferred. That is what you have to remember. Everybody clear? All of you? Yes, please. So without medium, sound cannot be transferred. Always some medium is needed. That is what is that, right? A matter or a substance, a matter or a substance, through which a wave propagates. A wave propagates is called medium. So it may be a what? Example, it may be a solid medium. It may be a what? Everyone? Liquid medium, or it may be a gas medium. So any medium, sound definitely needs a medium to propagate. If it wants to transfer from one place to another place, definitely it needs medium. That is what. So in which medium sound travel faster? Anybody? Niroshi, Darshana, Pradhana, simply attending, no response.
Ours,
Which medium
gas,
sound will travel faster?
gas,
Gas.
our
Wow,
medium.
super. So sound will transfer faster in solids. So please remember, solid to liquids, liquid to gas. The the speed of sound decreases. Speed of sound decreases from solid to liquid, liquid to gas. Light will travel faster in gases. Sound will travel faster in solids. Please remember, sound can travel faster in solid mediums only. Next, types of waves. This is very, very important one. Entire chapter rely on this only. Types of wave. First one. On the basis of a type of vibration, so these particles of medium waves are classified into two types. So one is basis of vibration. One is transverse wave and the second one is longitudinal wave. First one is transverse wave. Second one is longitudinal wave. Okay. So medium definition. Okay, finish it. Any doubt? Clear, Mr. Lingesh, Kishore? Solving ah. So now waves are two types based upon what? Everybody. Based upon the type of vibration. Based upon the type of vibration of the particle, we used to make it actually two types of waves. One is what? Transverse wave, and another one is what? Longitudinal wave. Now, we are going to discuss transverse waves. This is the most important one. So please remember, because entire our sound chapter, we are going to convert it into transverse waves and then we are going to make it. Okay, guys? Yes? So because we cannot study the properties of a sound in the form of longitudinal, so we must need to convert it into into transverse waves and then we are going to study. So let us start now, everybody. Transverse wave, keep heading all of you. Transverse wave means, so for example, imagine if you have been taken, suppose there is a rigid surface. Let me imagine there is a wall. There is a wall. Now for this, there is a hook. Attached hook is there. Now you tied a one rope and the rope, another end you are holding with your hand. Now, just if you give a jerk to this rope, have you noticed that? Actually the rope is mean position. Rope is present in a straight line if you have been stretched it. Now from the mean position, just if you give a jerk to it, have you noticed this? The rope will immediately will turn up into like this waveform. Am I right or wrong? Everybody, movies also you might be notice it. The hero will keep
Yes, sir.
exercises. Am I right, guys? Please respond. If I give a
Yes,
jerk
sir.
at this end, so what will happen? The motion of the thread will start moving like this. Is it right? Please respond, everybody. All of you. So every particle will start rising up and going down and rising up and going down. So whole particle, whole body will transverse. Is it right, guys? Please respond, guys. All of you.
Yes,
Yes.
sir.
Yes, sir.
This is only the every particle from its mean position, it will go up and down. This is only we used to call, yes, Mari, Jim, we can notice it. So this is what we used to call it as vibration. So basically, this is only known it as we used to call transverse wave. So transverse waves are those waves in which the particle of a medium vibrate perpendicularly. See that this is the mean position going up and coming down. Both are perpendicularly to the mean position, perpendicularly to the direction of propagation of the wave. Wave is moving like this way and motion of the particle is perpendicular. Both are perpendicular or not? Yes or no? Please respond. This is the motion and this is the displacement of the particle. Yes, please, guys. Who is that making noise? Mute. Gokul Raj. No attention. Tomorrow I want to see your physics classwork and chemistry classwork. Understand, Mr. Gokul? Already last 3-4 days you are absent. I will check tomorrow. Okay, everybody clear? Please respond, guys. Everybody? Yes? So, the particle motion is perpendicularly to the wave motion. That is what we used to call it as transverse wave. So, that is very, very important. So, in transverse wave, each particle will displaces perpendicularly to the direction of motion of a wave. That is what you have to remember. Hope you all understand. Anybody having any doubt, please let me know. All of you. So, finish it. Completed, then we'll write a definition, right? A transverse waves, a transverse waves, understand Shivani? A
Yes, sir.
transverse waves are those in which the particles of a medium, the particles of a medium vibrate perpendicularly. This is very, very important. Vibrate perpendicular. Perpendicular symbol is inverted T. To the direction of motion. To the direction of propagation of wave. Propagation of wave. That is what we used to call it as transverse wave. Hope you all understand. Please respond, guys. Everybody? Yes. So while you are disturbing this any kind of a rope or a string, the one end to give up and the another end it will notice it. One end if you give the jerk, just then it will travel up to the last by everything perpendicularly to the motion. So this is what is basically wish to say is wave. If you disturb any kind of a string or a spring or like a, sorry, anything rope or kind of thing, so from its mean position, they will start going up and coming down and going up and coming down. So that is only ways to call it as, yeah, rubber band. Rubber band not Gokul. Rubber band you cannot be. Rubber band is elastic in nature. That is not it is. Okay. Clear everybody? All of you? Please respond, guys.
Yes, sir.
Yeah. So now, let us see now. If you have been taken a rope or a string, any kind of a string, if you have seen that, how it will be produces the wave. The wave which is produced by the spring, sorry, not spring guys, string. Because spring will come under longitudinal wave. That's why I'm not talking about spring. It is a what, everybody? String, okay? Sometimes I may mispronounce, so you don't get confused. I'm talking about now string. String means what? I can say, example, rope. Clear everybody? All of you, please respond, everybody. So I can take about rope. So the rope will produces, this is what. So all of you notice it here. This is the direction of travel, means direction of propagation. So it, from here it is going. Direction of propagation is this one. But what about the displacement? Displacement of the wave is what? This is only the amplitude. Amplitude is only called as displacement. Of course, the terms we'll study. Don't worry. Clear everybody? Yes, please. All of you?
Yes, sir.
Yeah. So the displacement is perpendicularly to the propagation of sound. That is what you have to remember. Is call it as, we used to call it as transverse wave. So I hope you all understand. Now, in this figure only, I want to mention you all. So if you notice in this figure, so please learn the with the spellings, everything. So all of you write it. The portion, if you notice the string which is rises up from the elevation, from the mean point, which is rises up, we used to call it as a crust. CREST, crust. So wherever it is rising up, which we used to call it as a crust. Please write it. Similarly, wherever you are seeing the depression, what is this call it as? What is this call it as, everybody? This is call it as depression. Depression, wish to say. So wherever you see the depression, see displacement is perpendicular. So everywhere the displacement either up or down, we used to call it as amplitude. What is to call? What is to call, everybody? Please respond.
Amplitude.
Amplitude. Now upward, positive x-axis, we used to call it as a crest. CREST, crest, representation is capital C. Now depression, down, the depression, which we used to call it as a trough. TROUGH. Learn the spelling also, trough. Depression, which we used to call it as trough, and upward, understanding, rising up, that we used to call it as, where we are seeing the elevation. Elevation, we used to call it as a crest. Clear, guys? Understand, ma, girls? All of you? So whenever the rising up, this is what elevation. Elevation, call it as a crest. Depression, call it as a trough. Elevation, crest with the capital C, trough with the capital T. So please note it. Any doubt, anybody can ask me. Okay, guys? All of you? Yes, please.
Yes, sir.
So if it is showing the crest, now itself, yeah, 1 minute, I will erase it and I will come back. So if it is showing the upward, this is only the graph for displacement and distance graph. So please write time versus displacement distance graph. What is this graph? We used to call it as, what is this graph?
Displacement distance.
Displacement and distance graph. If I draw the displacement and distance graph, of course, displacement and time graph will come. That is different. Please note it. This is the graph, displacement and distance graph. My amplitude means maximum displacement, either up or down, whatever it is. Understand, Abhrami? Up or down, maximum displacement. See, this is also elevation, also amplitude, depression also amplitude. Is it okay, guys? Please respond, guys, everybody. So now we are discussing what? Displacement versus distance graph. Displacement and distance graph. So please remember that. Displacement versus distance graph, if you have been seen here, crust, upward, what we used to call? Upward, what we used to call? Upward displacement, elevation, crust. Am I right or wrong? So whenever it will shows the crust, that is call it as a positive displacement. What is to call, everybody? Crust is
Positive.
positive displacement because it is a plus x and this is, sorry, plus y, and this is a what? Minus y. Positive displacement, maximum displacement. This is trough, 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 trough. We used to call it as a what? Everybody, negative displacement. Negative displacement. Okay. And this is the distance traveled by the wave. Distance. This is the distance traveled by the wave. Whatever the wave travels, that is what we used to call it as distance. Now, the most beautiful and important thing I want to say you, that is what actually, Are, who is that fellow? Huh? That is what is called it as wavelength. What is to call, everybody? What is that called it as?
Wavelength.
Wavelength. Wavelength means, remember, what is this one? This peak point, what is to call? Elevation. Anybody? Crust.
Amplitude.
This is also what we used to call crust. This is also
Yes.
called it as a what? Crust. This is we used to call it as a what? Trough. This is also we used to call it as a what? Trough. So wavelength means, see, mathematics we say successive. So can we say the rise of amplitude or displacement as the effect of wave? Yes, Mari. So now the distance between two successive crust. See, this is the first crust, this is the second crust, this is the third crust. You can take any two. Any two means side by side. That is what you have to measure important. First and second, the distance between the two successive crust is called it as wavelength. Wavelength means generally we'll say in speed. Speed is equals to distance by time. This distance only call it as a wavelength. Please remember. Lambda. What is the symbol? Lambda. Lambda is the symbol for wavelength. Or you can take second and third. That is also call it as a wavelength only. Or you can take trough and trough. That is also call it as a wavelength. If fourth way here is there, then this also call it as a wavelength. So, distance between any two successive crust or successive trough is call it as wavelength. Is it okay, guys? Everybody? Please respond, guys. All of you?
Yes, sir.
Yes. So anything you can call it as a wavelength. Either crust, but successive. What do you mean by successive? Side by side, which we used to call it as successive. Very, very important. Next one, the graph, second graph. So first graph is displacement versus distance graph. Second graph is time versus displacement. Displacement time graph. Again, same. Understanding? Displacement and x-axis is the time. So please note it. So time graph. Displacement and time graph. Both are very, very important. So please learn up to here. So when we plot the displacement of a particle along with the time, then this is the graph. X-axis, time, y-axis, displacement. Maximum displacement we used to call something. What is to call? Maximum displacement. Just now I said.
Amplitude.
Amplitude. So please note it. Maximum displacement is known it as amplitude. Is it okay, guys? Everybody? Clear? All of
Yes.
you? Yes. So please make it. Anything doubt, please let me know or else we'll proceed further. Is it okay, guys? Yes?
Yes, sir.
So this is what is actually. So about the transverse waves. So transverse waves means you have to remember what? Crest, trough, wavelength, amplitude, displacement and distance graph. And then next one is what graph? Everybody.
Displacement and time graph.
Displacement and time graph. What is the major keyword in the transverse waves? You have to remember perpendicular to the direction of propagation of wave. The particles of a medium vibrate perpendicular to the direction of propagation. That is only the keyword. Hope you all understand. Anybody having any doubt, please let me know. Clear, guys? Everybody? Love you. Yes, please.
Yes, sir.
Yeah. So learn till here. Then tomorrow we are going to start. So what is the example for transverse wave? Stringa, springa. String, no spring. Clear? So learn from here. Then tomorrow we are going to discuss longitudinal waves. So in that, what is happening? That is all we'll discuss. And then we'll proceed production of sound. See now, till longitudinal sounds, prerequisite we says. What is needed the information to study this chapter better? That is what types of waves. So that is only the very important in 11th class also. That is a basic, very basic it is. So that's why. So have a glance and again, once again revise by morning, and any doubt, anybody please ask me. And from there we'll continue in the tomorrow's class. Thank you everybody. So please learn and I'll seize that everyone. Can you repeat the statement again that 90? What is the 90, Abhirami? I don't know.
So
Perpendicular.
you say now also that
That is the
perpendicular.
definition of transverse wave. Definition of transverse wave what? The particles of a medium vibrate perpendicularly from its mean side. That's all. Okay.
Okay.
Yeah. If the wave is transferring, it will go perpendicularly to that. If wave is going, whatever the direction of it is perpendicular. That's all. The direction of displacement. Okay.
Okay, sir.
So with this, I'll stop. We'll continue from here. Thank you, everybody. Hope you all understand. We'll meet tomorrow.